Eric Burgess here, and we've been asked the following. The height of randomly selected men is given in inches. Then we have all this data. It says, estimate the mean height of all men with 95% confidence. Assume the variable is normally distributed. All right, so we know that the formula we're going to need, so this is a confidence interval because we're trying to estimate the mean. That's so the keywords here are estimate and confidence. And so we say, okay, well, what kind of confidence interval is it? Is it a T confidence interval or is it a Z confidence interval? And looking at this, we see we don't have very many samples. And we also don't have a population standard deviation. And so we know this is going to be a T confidence interval. Those things inform us that we're going to be using a T confidence interval. And remember that the T confidence interval is our best point estimate. And our best point estimate of the mean is the sample mean. And then we could be below the true mean. So we would have minus and then some error. We're going to call it E. And then in the middle is the true mean, the population mean. And then on the other side, we're going to have our best point estimate plus some error. We could be above it by some error amount. And now the formula for that error is determined by our distribution and also by our sample. And so we'd say this minus our T of alpha over 2, because there's going to be error above and below, so our alpha gets split in half. And we're going to have it be multiplied by the standard deviation S divided by the square root of n. That's going to be our expression for the error. And you could just look this up as a formula, but this is sort of the meaning of the formula. So then we're going to add the error, which is T alpha over 2 S over the square root of n. All right, great. Now we know it's normally distributed. We were told that. And we were not told alpha, though. So our alpha, that's going to be equal to, well, if we're confident by 95%, alpha is how much we're not confident by. So there's 5% we're left with that we're not confident. So there's 5% we're not so sure about. And we know that this is going to be like two tails because it's an interval of confidence. So there's going to be an area above and an area below. And, well, these don't look very symmetrical, but pretend they're the exact same on both sides. And this is going to have 2.5% of our alpha. And this is going to have 2.5% of our alpha. So there's a chance that our estimate is wrong, that it's out here in this black region, but it's not very high. It's only 2.5% chance above and below, so 5% total. And this is why confidence intervals are always two-tailed. So, all right, so now that we've got everything that we need, let's go ahead and get this ball rolling. So first up, we're going to need to get our statistics out. So we were given straight data. And the calculator actually has a confidence interval built right into it. So let's go ahead and use that first, and then we'll also do it using the chart. So if we come into our calculator, there is a great place to put our data in. So if we hit Stat and then go to Edit, we can put it in our first list. If you have stuff in your list, just go up to List 1, like the name, and hit Clear, and then push down. And the list should clear itself. All right, so we've got 60. We've got 54, we've got 50, we've got 56, we've got 64, we've got 49, 53, 52, 50, 53 again, and 57. All right, sweet. So there are our numbers, and I'm just going to go through and really quick make sure I didn't miss anything. And on the test, I highly recommend doing this. Go back and just consciously make sure you put everything in right. All right, so now that we have that, we're going to go to the confidence interval. We want a T confidence interval, like we explained before. So we're going to go to Stat, and then to Tests. And if we scroll down here, we're going to look for an interval. So we see a Z interval already, but we don't want a Z interval. We want a T interval. So number 8 is going to be what we want. Now, we have not computed the statistics. Remember, statistics are computed from our data. We haven't done any of that. We weren't given the mean or the standard deviation or any of this stuff. And so we're going to tell it, hey, use data. By telling it to use data, we're basically saying we calculate this stuff for us. That's what we're saying. So, okay, and the data is in list 1, so that's correct. If it's not, you can choose the list. They're here in blue, so like list 5, list 4, list 6. So if you put it in some other list, just hit the blue key and select the list that you wanted. Leave the frequency as 1. Confidence level is 0.95, so that is exactly what we want. We're going to hit calculate. It's going to do a little thing for us. And it gives us the X bar in the mean, which is really convenient. I'm going to write it down really quick. So 0.36, because we're going to use it as a reference when we check our stuff. And S is equal to 4.59. And our N is 11, which is exactly correct. And then it gives us this interval. So this is the lower end of the interval, and this is the upper end of the interval. So we're saying that the true average height of men for the population is somewhere between 51.281 inches. And depending on your teacher, you may or may not have to interpret this. And 57.446. So we're saying that we're 95% sure the true mean for the height of men is between these two numbers. And so we've narrowed it down somewhat. All right, so that's how you do it using the calculator. Pretty simple. You may write out a sentence saying that we estimate that the true mean of the height of men is between 51.281 inches and 57.446 inches. You know, be very formal, really demonstrate that you know what you're saying. Now let's go ahead and do this using this formula. So if you're going to use the formula, we're going to need to compute, since we weren't given X bar and S, we're going to need to compute them. And so X bar and S have formulas that you can use. They're not too bad, but S is kind of a pain to calculate. So I'm going to show you how to do it using the calculator again, but just a different way. If you go to stat, so you put all your numbers in like we did already. If you go to stat and then to calculate, one variable stats will actually do it for you. So if you hit 1 and you go down to calculate and you give it the right list, give it list 1, it's going to do it. And in here, we see that SX, and we want the S version because that's the sample standard deviation. And we were given a sample, so we have to use the S version. That's 4.59 rounded. So that is exactly what the test gave us. And if we look at the mean, that's 54.36, which is also what the test gave us. Now, if you really want to, you can go and look up the formulas for these and calculate them completely by hand, which more power to you. But the problem didn't state that we have to do it that way, so I am going to run with this way. So there we go. We've got our two values here. The only one we're missing now is T of alpha over 2. So remember, confidence intervals are always two-tailed. And you can actually, these values here, this is the value that would go right here. That would correspond to this. And this is the X value that would correspond to this. And then all the ranges in the middle are the ones that we think are within a reasonable guess, a 95% confidence. So, okay, we need T of alpha over 2. We know our alpha is 5%, and half of alpha over 2, that is 2.5%, or 0.025. And so we're going to look up on the T chart. So let's go ahead and go to a T table. And, we need to talk about degrees of freedom. Degrees of freedom, that's just one less than your sample. We have 11 points. And it actually in the calculator will tell you, or you could just count the number of points if you're doing it totally by hand. So we might write down degree of freedom is equal to 10. It's a two-tail test, two-tail. And we want to look up an alpha of 5% or 0.05 in two tails, or in one tail. It's going to be the same in both tails. We're going to have an alpha of 0.025. And you'll see really quick what I'm talking about. So we're going to come over to the T table, and we're going to look for our degree of freedom of 10. So it's this last bit on this blue line here. And then we're going to look. Your t-table may look slightly different, but they say the same things. Now we're looking for a two-tail test here, or a two-tail alpha. And in two tails, there should be 0.05 because we said 5%. I'm covering up the chart a little bit with the calculator. So we go down the two-tail and we look for 0.05. Here it is, and here's 0.025 in the one-tail row. So this checks out with what we're looking for. So now we're going to come down to 10, and we see that the t-score is 2.228. So that's the one we're going to use, 2.228. So let's go back to our problem here, and we say that t of alpha over 2 is equal to 2.228. So now we can plug all this stuff in. So our x bar is 54.36. I'm just plugging it into the formula we have. And then we're going to type minus and then 2.228 for alpha over 2 times s. S is 4.59 divided by, and then the square root of n, square root of 11. Less than the mean. And then we do the same thing. 54.36, and this time it's just plus 2.228 times 4.59 over the square root of 11. It's the same exact thing, it's just one side has the plus because it's adding the error. So all right, we can type this into our calculator here. So we're going to turn it on, and we're going to just clear it. We're going to just type this in. So 54.36 minus 2.228 times, and then we're going to have a fraction. So fractions in the F1 menu. So we hit the green key and then we hit F1, and there we go, fraction. That's the first option. I did that kind of fast. And now we do 4.59, and square root key is right here in blue. So we hit the blue key, color coded, and the square root of 11. And then we close off our parenthesis, and this is going to be the lower interval, which we expect to be 51.281. We hit enter, and we get 51 point, and then we've got some differences in rounding. That's totally okay. We are extremely close. We would have 51.28, and then over here it varies some, but we see we get an extremely similar number. This is actually more accurate probably, just because the rounding that occurs on the chart could be a little more severe. But anyways, extremely close number, so we're good there. Now, to get the positive side on the calculator, you can actually just push up till the calculation's highlighted, hit enter to copy it. We could come over and just change that one sign to a plus, because there's no point in retyping it all, just put a plus there. So now it's this side, it's just plus this error. We hit enter, and we get 57.44, and look at that. Again, extremely close. So this is a great way to just check our work and say, hey, we get the same exact interval. And it just kind of shows you that's how the calculator does this thing. So great way to check your work. If you have any questions about this, let me know. Subscribe, and if you're a Citrus College student, stop by online tutoring, of course. If you need any extra help, we're there for you. And we'll catch you in the next problem.